Okay, I want to talk a little bit about a subject in chapter 14, gathering like terms. As you can see, I put an equation on the board right here, and this is the one with the variables all the same, 9d plus 2d plus 5d plus 1d. Most students can get this particular kind of problem because we use the same variable. Let's say that you and your friend want to order a pizza. And you have your $9 and you're counting on your friend to come up with some cash in his pocket so you can afford to go and order a pizza. Well, let's say he has $2 in his pocket and maybe he finds $5 more in his car and maybe even $1 more stuffed and lost in the sofa. And he's kind of a slob. So let's see, you add this up together, 9D, 2D, 5D, and 1D. And what do you get? $16, $17. So as you gather the like terms, these you can actually add together. And it turns out that you and your friend do have enough money in your pockets to get a pizza. However, let's take a look at this particular equation. Now this one my students have a little trouble with, and traditionally the terms x squared, and x cubed is where they get a little bit confused. These are not like terms, okay? So I've actually got some visual aids to kind of help us cement this down. The x is going to represent a stick or a one-dimensional object. The x squared would be something more like a square right here, a two-dimensional object. And the x cubed would be a three-dimensional object, this one of these cubes right here. So these are not like terms. So one of the things that I see on exams and quizzes is they want to add these numbers together to get, let's go to the next one, to get 10. But 10 what? Would it be 10 cubes, 10 sticks, or 10 squares? As you can see, these are not the same objects, so you can't gather these like terms. So don't make this mistake. Okay, so I put an example here on the board that I found in your book. I'm going to kind of teach you a little technique to help you that I've shown to other students that might help you learn how to gather like terms. So let's pick up one of our sticks here. And you can see that this has got x's, x squares, and x cubes. So a technique that I use, and I've taught to my students in the past, is to let's look for all the x cubes in this equation and just underline them, and that way we can keep them straight. So we've got one x cubed here, and it looks like I found another x cubed right here. And whatever you do, you can use boxes, a double underline, whatever you like to do to keep it kind of straight in your head, you can use. Okay, so here's an x, and why don't I just double underline that one? And this is an x squared. Let's see, I found another x here, so I'm going to double underline this one. And then that leaves me with x squares, and I'm going to circle these. Okay, so this kind of takes some practice for some students. What you want to do is use a little bit of logic, and then you can use the arithmetic. So you can do it either way you want to. You can find all your x cubes and then gather them and say 1x cubed plus 1x cubed, and you know that's 2x cubes. And then you can use your arithmetic here, 2x plus 3x. That's going to give us 5x. And then I gather and find all my circled terms are my x squared terms. So I've got 4x squares here and 2x squares here. So that's going to give us 6x squared. Now, I've already kind of went over this in another class. To get this 100% correct, you want to put the from lowest denomination up to the highest. So that's going to be a 5x, and then you use your x squares, 6x squared, and then you put your x cubes, which would be 2x cubes. Alright, so this would be the 100% correct answer. So let's check our answer and see if we got it. 5x, 6x squared, plus 2x cubed, and there we go, we got it.